Hello. So for today we are going to look at a question of vectors, and the question says, given that the coordinates of A and B are 6, 5 and -4, -8 respectively, find the distance of a point P from the origin where P divides AB internally in the ratio of 2 to 5. Give your answer to one decimal point. So this is a question of vectors where you have 2 points. So if I draw those 2 points here, I have the origin, that's point O. There's a vector going all the way up to this point here. Let's call this one here point A. And then there's another point from the position from the origin at that particular point. I can call that point B. And then, so this will be our vector A, and this will be our vector B. And you know the coordinates of A are 6, 5. And you know the coordinates of B are -4, -8. So there's a vector connecting these two, A and B, because you have been told that the line AB is divided in the ratio of 2 to 5 by P. So there is P somewhere here, dividing this internally in the ratio of 2 is to 5. If you want to know the position vector of P, we'll have to consider the vector OP coming from the origin, and keep in mind that the origin is the point 0, 0. So to be able to get the coordinates of P, we are going to use the ratio theorem, and in this particular case it will be equal to taking this value here, 2, we divide by this over the total of 5 plus 2, which is 7, and then this 2 goes with this vector on this side, which is vector B. But in this particular case, we write the vector OB as a column vector, which will be -4, -8, and then plus here we'll take this value here, which is 5, over the total, which is 7, and it will go with this line on this side, which as a column vector is 6, 5. So in this particular case, we are going to open those column vectors, so by multiplying the scalar by each of those coordinates. So when I take 2 over 7 times 4, I'm going to get -8 over 7. When I take 2 over 7 times -8, I'll get -16 over 7. That is the column vector when I multiply with the scalar. Then I add 5 over 7 times 6 is 30 over 7. And then 5 over 7 times 5 is 25 over 7. Then I add. When I take -8 over 7 plus 30 over 7, I'm going to get 22 over 7. And when I take -16 over 7 plus 25 over 7, I'm going to get 9 over 7. So this is going to be the position vector of P after adding those particular values. As a coordinate, it will be 22 over 7 and 9 over 7. Writing them as improper fractions, but it's good practice to write them as mixed fractions. But I'm doing this because I'm still working out the question. So if I want to get, the question is asking, find the distance of P from the origin. So actually they want the distance from that point all the way to there. Now if you want to find the distance between any 2 points, you are supposed first of all to get one column vector representing that particular vector. So in this particular case, if you want for OP, we'll take the value of P, we minus 4O, the end minus the origin, or the starting point. That will give us 22 over 7 and 9 over 7. And then we get the square root of the square of those 2 values. So here the magnitude of OP is going to be the same as the square root of 22 over 7, this one is square, and then plus 9 over 7, this one is also square. So in this particular case, it will be equal to the square root of, when you take 22 over 7 squared, I think we'll get 484 over 49, plus 9 over 7 squared, we are going to get 81 over 49. And then when we add these ones, we'll get that will be 565 over 49 squared, square root, not squared actually, we are square rooting. So in this particular case, I'll work out the value of 565 divided by 49, and that will give me approximately 11.530612244898, and I need to get the square root of that, and the square root of that will be approximately 3.3956. But the question wanted us to give the answer to one decimal point, so if we do that, our answer is going to be 3.4. And since we are giving the size of a vector, we are going to give our answer in terms of units, and that will be our final answer. So the main principle here is that if you're dealing with internal division of a vector, always know you take one side, that is 2, and then over the total 7 you multiply by the opposite vector, and then you take 5 over the total times the opposite vector to be able to know what will be the column vector for that point P, and also the coordinates. And keep in mind, when you're dealing with coordinates, you write them horizontally, and for column vectors you write them vertically. So I hope this has been understood. We'll stop there for today. Have a nice time. We'll meet again tomorrow. Thank you.